usual sources of fats for chocolate manufacture are cocoa butter beans or specialty fats obtained from vegetable oils. Specialty fats are normally referred to as cocoa butter equivalent, CBE, and cocoa butter substitute, CBS. The CBE is formulated using palm mid-fraction and other exotic fats. The CBS is derived from processed palm kernel oil, and they are highly suitable for coating. Palm kernel oil can be fractionated to give palm kernel stearin, with similar physical properties to that of cocoa butter. The stearin is suitable for coating and molded chocolates. Non-lauric CBS is made from oils such as palm, soybean, cottonseed, and peanut oils. They are hydrogenated to make the fat harder. Plain chocolate contains sugar, cocoa mass, 10% cocoa butter, and 5% CBE. Milk chocolate contains sugar, full cream milk powder, cocoa mass, 15% cocoa butter, and 5% CBE. In chocolate pastel, the cocoa is omitted. The color of chocolate pastel is basically white, and color can be added to make it more attractive. Manufacturing process. Raw materials, for example, cocoa liquor, sugar, and milk powder, are mixed with an adjusted fat content at roughly 26% before the mass is refined. Chocolate paste is refined usually with a roll refiner to obtain the required smoothness. The mass is ground until 80% of particle size distribution is between 20 to 30 microns. Conching is a decisive process to produce good quality chocolates as physical and chemical changes occur for the development of flavor and flow properties. Temperature control is between 65 to 90 degrees Celsius for plain chocolate and 50 to 65 degrees Celsius for milk chocolate. The duration is dependent on the composition of the mass, but it is normally more than 3 hours and often longer for plain chocolate. A homogeneous product mass is produced in the homogenizer. Tempering of the chocolate mass based on CBS is carried out by heating it at 50 to 60 degrees Celsius and cooling it to at least 2 degrees Celsius above the quoted slip melting point of the fat, which for plain chocolate is between 26.5 to 27.5 degrees Celsius, and for milk substitute between 25.5 to 26.5 degrees Celsius. For CBE-based chocolate, it is necessary to form the right amount of stable crystal in the chocolate mass to enable molding. Temperature of the mass is raised to 31 to 33 degrees Celsius for plain chocolate and 29 to 31 degrees Celsius for milk chocolate respectively, before molding. The chocolate mass is filled into the mold, tapped and strapped of excess chocolate. Temperature of the mold should be 2 to 5 degrees Celsius lower than the molding temperature of the mass. The chocolate is then cooled in a cooling cabinet set at 5 to 12 degrees Celsius. A cabinet with air circulation and sufficient cooling capacity should be used. Cooling takes place between 5 to 12 degrees Celsius for between 15 to 20 minutes up to a maximum of 45 minutes. For easy demolding, the shrinkage should be sufficient. Difficult demolding may result from insufficiently clean molds, improperly tempered chocolate, or inappropriate temperature set. The finished products are stabilized at 18 to 20 degrees Celsius for at least 24 hours to complete crystallization. Advantages of using palm-based fats in chocolate products. CBS-based chocolate crystallizes rapidly into stable beta-prime crystal form, eliminating tempering needs and consequently reducing processing time. Chocolate made with CBS has a good resistance to fat bloom, creating shiny and attractive products. The same production plant for pure cocoa butter chocolate can be used. Palm-based chocolates are more stable in hot climates than non-palm-based chocolates due to higher solid fat profile at increased temperatures. However, the chocolate still melts in the mouth due to the stiff melting profile of the fat. Palm oil and palm kernel oil are ideal raw materials for the production of specialty fats due to their excellent physio-chemical properties. They can be further modified to extend their range of utilization.